Hi everyone, and welcome back to Maths and Physics Mr. Simons. Today's grade 11 trigonometry lesson. We're looking at identities. Right, and I'll start with finding products. So everything we actually teach you in algebra, we also test under trigonometry. Right. So we'll be looking at these 4 problems. Prove that the following statements are identities, meaning must prove that this left-hand side is the same as the right-hand side. So there, number 1, sine theta plus cos theta all squared. Number 2, we have sine x plus cos x squared plus sine x minus cos x squared. 3 cos x, 1 plus tan squared x. And then number 4, 2 sine x minus cos x, 2 sine x plus cos x. Now I've put the sheet here. You can attempt to do them, see where you get stuck. Then look at the solutions and see if you can work and correct your errors, right? But as you can see there, all of them involves multiplication, right? So let's look at problem number 1. Now in short, identity is a mathematical statement that is true for all values of the variable, excluding the values for which the statement is not identified. Now started with number 1. They have 2 terms in a bracket and they're all squared. Right, and the key concept we're going to catch you out with here, and we do it every year when we mark grade 12 papers. You'll forget that my answer must have 3 terms. Right, so if I say left-hand side, I'm going to say sine theta times sine theta, gives me sine squared theta. Cos theta times cos theta, which gives me cos squared theta. But for the middle term, it's sine theta times cos theta times 2. Then gives me 2 sine theta cos theta. So if you forget this middle term, the whole sum becomes wrong. Right? Now I'm going to group sine squared theta plus cos squared theta together. Now I'm left with plus 2 sine theta cos theta. Right? According to the square identity, sine squared theta plus cos squared theta equal 1. So therefore that becomes 1 plus 2 sine theta cos theta. Right, so my left-hand side now is the same answer as my right-hand side. Therefore, the identity is true. Right? Let's look at problem number 2. Now we have sine x plus cos x squared plus sine x minus cos x squared equal to the value 2. So again, don't forget the middle term. I'm going to repeat this over and over. I'm tired of marking where you'll forget the middle term. There are 2 terms in the bracket and it's being squared. So my answer must have 3 terms. So sine x times sine x, sine squared x. Sine x times cos x times 2 becomes 2 sine x cos x. Cos x times cos x becomes cos squared x. Yeah, sine x times sine x, sine squared x. Sine x times cos x times 2 gives me negative 2 sine x cos x. Then cos x times cos x gives me cos squared x. 2 sine x cos x minus 2 sine x cos x cancels. So I'm left with sine squared x plus cos squared x, sine squared x plus cos squared x. Now according to square identity, sine squared x plus cos squared x equal 1. Sine squared x plus cos squared x equal 1. So 1 plus 1 would then give me 2. So I hope we're still together. Right, now problem number 3. So far, if you're enjoying the lesson, please like and subscribe. Share with somebody that needs help. I'm doing this to help as many people as possible. So I'll highly appreciate it if you share it with somebody that needs the assistance. So number 3, we have cos x in bracket 1 plus tan squared x. We must make the left-hand side equal 1 over cos x. So there, cos x times 1 gives me cos x. Cos x times tan squared x give me cos x tan squared x. But we should know from my quotient identity that tan squared x is sine squared x over cos squared x. Alright? So from there, cos x divides into cos squared x and leaves the cos x behind. So I'm left with sine squared x over cos x. And here, cos x over 1. To add this fraction here with a cos x to that fraction there, the denominators must be the same value. So therefore, because it's cos x over 1, I'm multiplying by cos x over cos x. So cos x times cos x gives me cos squared x. And then cos x times 1 gives me cos x. So you can see now this fraction and that fraction has the same denominator, cos x. So the denominators are the same. We can add the numerators. So now I have cos squared x plus sine squared x. According to square identity, cos squared plus sine squared gives me 1. So therefore, 1 over cos x equal to my right-hand side, right? Forgot to type in there. It should say equal to right-hand side. Right, prove the following. So number 4, they gave me 2 sine x minus cos x times 2 sine x plus cos x. And I should get 5 sine squared x minus 1. Now the two brackets are the same, but the one is positive, the other one negative. So there I'm dealing with what you learned in grade 9, difference of 2 squares. So 2 times 2 gives me 4. Sine x times sine x gives me sine squared x. Negative times positive gives me negative. Cos x times cos x gives me cos squared x. Right, because my final answer only has sine squared x. My apologies there. Because the final answer only has sine squared x, I'm going to change cos squared x to 1 minus sine squared x. Right, according to the square identity. So from here, that becomes negative 1. Negative times negative become positive sine squared x. So 4 plus 1 sine squared x gives me 5 sine squared x minus 1, which then equals my right hand side. Right? And there I've proven that identity. Right, in the next video I'll be looking at taking out common factors. And if I have time, I'll do more and more problems of identities, because I've seen it's something that if we don't do enough practice of it, still catches you out. But now I'm just going through the variation. So I'm going to do another video on common factors and factorization. Then I'm going to do one on fractions. And yeah, then we're going to look at some more complex problems. God bless. Bye.